2021 question 7. What's the difference between HTTP, Hypertext Transfer Protocol, what the web works on, and the secure version of it, HTTPS? Okay, well, that's one right there. One's got an S in it. I don't know if you can write that down. But basically, one is more secure. It's the one with the word secure in it, if you're wondering. It also uses port 443, the secure one. Whereas regular HTTP uses port 80. What does that mean? What do you mean ports? Ports as in when you connect to something, you type the IP address, and sometimes when you're connecting to a computer, you have to say what port you want, what door you want to go to get into it. Okay, so it depends what you want to do. If you want to get just some files off a server, you might be using FTP. So you'll need colon and what's FTP, like 20 something. But I know, for example, HTTP, if you're just making a regular web server, it'll be 80 or 8080 sometimes. But if you want a secure one, you've got to go colon 443. Okay, so let's say I'll just show you here. This is a cool camera app called TinyCam. Oops. And what this does is, if you buy a load of brands of different like cameras off Amazon for cheapo, and they all come with these like subscription models where you have to pay this. We're like, nah. You can just download a little Android app, and you just type in the IP address of your camera, and give it a password. You can see them all then on one screen. So I can see this example here that I got off Google Images has got its web port is 80, so that is normal HTTP. Okay, whereas if you want a secure connection to your camera, which you might want to do if it's just a security camera outside your house, you might want to check this box. When you do this on the app, will change to 443, and if you're connecting to something via browser, generally you just put a colon on the port after the IP address. Okay, so that's what ports are. They're basically just like doors into your computer. Okay, some of these are closed by default. So if you go to a bank, you'd imagine that a lot of their computers have most of these ports closed. So not only can you not sit there and tap on the this, let's say, FTP port here to try and get some files and guess the password. There's no point in guessing the password because that port is closed on the computer. You can't even, there is no door to be knocking on, so yeah, that's why it's a good idea to keep most of your ports in your PC closed unless you need them to be open for whatever reason. Grand. Okay, so let's look at some other things. HTTPS, it needs a certificate. So when you contact a server, instead of just being like, let's have a chat, it says, wait a second. It's like someone comes to your door and you ring the doorbell and it opens and a guy's there saying, hello, I am Google. And you're like, are you? You don't look like Google. You look very, very shady. And he's like, rats. And he walks away. And then Google comes back in a Google t-shirt with a Google certificate, looks like a proper Google nerd. So maybe, it's got basically like the authorities call to your door, the authorities, and you want to see some ID. That's HTTPS. All right. That's the difference there. So, because basically, if you think about it, right, you could have a fake bank website and it could be like, I am the bank. And unless you see a certificate, your computer would be like, hey, I noticed that this certificate doesn't look right. What can also mess up with your computer is when you change the time and date in your computer, because the certificate is on that. The certificate could be out of date, and that's why sometimes if the clock is wrong in your PC, you can't browse, and especially sites that have HTTPS. HTTP is just Wild West, doesn't care. And HTTPS is encrypted. Right. So let's have a look at what the marking scheme was saying there for that one. So much the same what we were saying. One secured. There's a difference in ports. The application layers, transport layers. I'll talk about that in a moment. And we talked about certificates. So, okay, let's talk about layers for a moment. So these are the layers in the OSI model. Basically, it's kind of like this is how computers are built. Well, networking computers. They all kind of sit on top of each other. And the way you remember this was a great video by this guy. I love his mnemonic of all people should try new Domino's pizza. That's very easy for me to remember because, you've had Domino's pizza. That'll be burnt into the back of your brain. So, So basically the way this works is that, in HTTPS and HTTP, they work at different layers. So you can see up here the application layer is HTTP, but actually HTTPS is, I think it's down here, the transport layer. Yeah, it is. Yeah. So it's just down a bit. So that's the last difference. Let's look at part B. Part B was talking about what is TCP. TCP. It sounds fun to say. Well, so both TCP and UDP are just ways in which computers, two different protocols in which computers can talk to each other. All right. UDP is much easier. It's way more basic than TCP. It's more like, I found this radio. It made a cool noise. Bleep, blonk. And I'm going to pick it up and I'm going to hold down the button and I'm going to say hello. Hello. This made a noise. And I'm now talking. And I'm going to do with my kid does. I just hold down the button and just keep talking. I'm not even going to let go of the button, so someone could be talking back to me right now. I don't know. I'm not really into acknowledgements. I just like talking. This is UDP. I probably should just pretend to be holding down a button and not actually broadcasting within a 5-kilometer radius of my house. This is YouTube. Welcome to the YouTubes. Whereas TCP is way actually more like real life radios, not these little dinky like VHF radios, which is upstairs somewhere. So I'm not going to get it. But I actually have a radio license for this. So I only realized this is exactly the same as how like real airplanes and boats talk. So let's say I'm talking, I'm Janie Mackers, a boat, is my name, a boat. I'm talking to another boat called Hullabaloo. Okay, so this is how TCP would work. Hullabaloo, 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 Janie Mackers, over. Janie Mackers, hullabaloo, go ahead, over. Hullabaloo, Janie Mackers. Yeah, now I can start talking, now that I know that you're actually listening. So thanks for acknowledging me. Acknowledgements. Again, why am I not just pretending to hold this button down? I don't know. So let's see what the marking scheme has to say about that. TCP, it breaks messages into chunks packets. Yeah. And then passes these on to the IP layer. I mean, you can see it in our layers thing there. The TCP, so it starts on the transport layer, goes down to the network layer, goes across to the computer, and then it's going to go back up. So the transport layer up here, or higher layers, will reassemble those packets. So yeah, reassembles the packets into the correct order. And then reliability, that's what we're saying, is achieved by a system of acknowledgements. Acknowledging people and timeouts. So it's the exact same as when you send someone a message. You would like an acknowledgement is a little blue tick. You can do this, by the way, if you type CMD and then type ping -t, your favorite website. Let's just say it's Google because I'm not being creative right now. There you go. You can see there's a timeout. Look. All right. A timeout of that. Oh, is it timing out there? I think it is actually timing out. Mad. So eventually that'll kind of like it'll say timeout and then crash out and give out. Oh, I've just hit Control-C to kill it there. So if acknowledgement is not received, it actually then sends it again. Okay. So we can imagine somebody just like continuously harassing you and resending a message because you haven't replied. That's TCP.